Welcome to this presentation on file handling in Python. In this session, we will explore how to read and write files and work with different file types such as text files, CSV files, and JSON files. To begin working with files in Python, we need to open them first. This is done using the open function. The syntax is simple. File equals to open file path, mode. The mode specifies how the file will be opened. For instance, R opens the file in read mode, W opens the file in write mode, and A opens it in append mode. There are also binary modes like RB and WB for reading and writing binary files respectively. Once a file is opened, we can read its contents. Python offers three primary methods to read a file: read, which reads the entire file; readline, which reads one line at a time; and readlines, which reads all lines into a list. For example, to read the whole file, we use file.read. Don't forget to close the file using file.close after you are done. When it comes to writing data to a file, you can use the write method, which writes a string to a file, overwriting the existing content. Alternatively, the writelines method allows you to write a list of strings to the file. In both cases, if the file does not exist, it will be created automatically. Be cautious as the write method will override any existing content in the file. Python supports a variety of file formats. The most common are text files, which store basic data such as letters or numbers. We also have CSV files, which store tabular data in a plain text format, and JSON files, which are lightweight and often used for data interchange, especially in web applications. CSV files store tabular data where each value is separated by a comma. To read and write CSV files in Python, we use the CSV module. The csv.reader method allows us to read the contents, and csv.writer helps us write data to a CSV file. In this example, we are using the csv.reader method to print each row of data from the CSV file. JSON files are widely used for data interchange. To work with JSON files in Python, we use the JSON module. The JSON.load method is used to read data from a JSON file, while JSON.dump is used to write back data to a JSON file. This is particularly useful when working with APIs or configuration files. File operations can fail for several reasons, such as a missing file or lack of permissions. To handle such errors, we use Python's try except block. This ensures that the program does not crash when an error occurs. For instance, if the file does not exist, a file not found error will be caught, and you can provide a custom message. Now that we have a good understanding of file handling, it's time to practice. Your task is to write a Python script that reads a CSV file, processes its content, and writes it to a new text file. Make sure to indicate error handling for potential issues, such as the file not being found or the format being incorrect. This exercise will help solidify your knowledge of file operations. Welcome to day 23 of our Advanced Python Concepts series. Today we will be exploring lambda functions in Python. I am excited to walk you through this powerful feature of Python. Let's begin by understanding what lambda functions are. Lambda functions, also known as anonymous functions, are small one-line functions defined using the lambda keyword. The syntax is simple. Lambda arguments expression. Let's look at an example. Here we define a lambda function called add. It takes two arguments a and b and returns their sum. When we call add 3, 5, it outputs 8. Lambda functions are commonly used for simple operations that don't require a full function definition. Lambda functions can also be passed as arguments to higher order functions, such as map, filter, and reduce. For example, we have a list of numbers 1, 2, 3, 4, and 5. We use map with a lambda function to square each number. The result is a new list 1, 4, 9, 16, and 25. Speaking of map, this function applies a given function to each item in an iterable. In this example, we use map with a lambda to double the numbers in our list. The result is 2, 4, 6, 8, and 10. The map function is ideal when you want to apply a transformation to every element in a collection. Another useful function is filter. The filter function filters out elements that don't meet a condition. For example, using a lambda, we can filter out even numbers from a list containing the elements 1, 2, 3, 4, 5, and 6. The result is 2, 4, and 6. This is helpful when you only want elements that specify a specific condition. Next, we have the reduce function from the functools module. It applies a function cumulatively to the elements of an iterable and reduces the iterable to a single value. Lambda functions are often used in practical situations such as sorting and filtering data. For instance, let's say we have a list of tuples 1, apple, 3, banana, 2, cherry. We can sort this list by the fruit name using a lambda function. The result is 1, apple, 3, banana, 2, cherry. Lambda functions make such operations concise and effective. Now let's talk about best practices. Use lambda functions when the operation is simple and you need it only once. They are perfect for short functions passed as arguments. However, avoid using them for complex operations. If your function is too long or complicated, it's better to use a regular function defined with def for better readability. Now it's time for a hands-on exercise. In exercise 1, take a list of integers and use map with a lambda to square each element, add 10 to each element, filter out elements that are less than 20. In exercise 2, use filter and a lambda function to remove vowels from a string. To summarize, lambda functions are concise, anonymous functions that are defined using the lambda keyword. They are especially useful in functional programming tasks like map, filter, and reduce. Lambda functions are best suited for simple operations or when you need a quick one-time function. Practice using them to write cleaner, more efficient code. Welcome to day 24 of our Advanced Python Concepts series. Today we will be diving into decorators, a powerful feature in Python that allows you to modify the behavior of functions without changing their actual code. Let's get started. First, let's explore what decorators are. A decorator is a special type of function that allows us to add extra functionality to other functions. In simpler terms, it wraps a function and modifies its behavior without altering its core implementation. Decorators are widely used in Python for tasks such as logging, memoization, and even access control. Now let's look at the syntax of decorators. A decorator is itself a function that takes another function as an argument. Inside this function, we define another function, often called the wrapper function, which is the one that will call the original function. Finally, the decorator returns this wrapper function. Here we have a simple example where we decorate the display function. The decorator underscore function line applies the decorator to the display function, adding functionality before the original code is executed. So how exactly do decorators work? When a function is decorated, the original function is passed to the decorator. The decorator then wraps this function inside another function that can add extra behavior. This wrapper function is the one that's actually executed when you call the decorated function. The decorator essentially intercepts the function call, performs some actions, and then either proceeds with or modifies the function's output. Next, let's see how to create custom decorators. Here's a basic example. The simple underscore decorator function takes another function as input and wraps it with additional behavior. Before calling the original function, it prints a message, and after calling the function executes, after the function executes, it prints another message. The output of this decorator is before calling function followed by the function's output and then after calling function. This is the this is the power of decorators. You can add custom behavior around any function. Decorators can also accept arguments. This requires an additional layer of nesting because the decorator itself now needs to accept parameters. In this example, we define a decorator underscore with underscore args that takes a message as an argument and passes it to the wrapper function, which then prints the message before calling the original function. This gives us more flexibility and makes the decorator more powerful. Decorators have many practical use cases. For instance, they can be used for logging, where you log every time a function is called. They can also help with authorization, ensuring that users have the proper access rights before allowing function execution. Another common use is memoization, which caches the results of expensive function calls. And of course, timing functions. Decorators can help you measure how long a function takes to execute. Python comes with several built-in decorators that make our lives easier. The static method decorator is used to define a static method in a class. The class method decorator defines a class method which operates on the class itself rather than instances. Lastly, property is used to define methods that act like attributes, providing a neat way to access computed values. Now let's try a practice exercise, a time decorator. This decorator measures the execution time of a function. We use the time module to record the start and end times, and the decorator prints the time it took for the function to execute. Here we apply the timer decorator to a simple function, slow function, which pauses for 2 seconds before printing a message. This shows this shows you how to create a decorator for measuring performance. To wrap up, decorators are an essential feature in Python that allows you to modify or enhance functions without changing their original code. From logging and memoization to performance tracking, decorators are widely used in Python applications. I encourage you to practice creating your own decorators. Understanding decorators deeply will significantly improve your Python coding skills. Welcome to day 25 of our Python course, where you will dive into generators in Python. Generators are a powerful tool for efficient iteration and lazy evaluation. Let's explore how they work and how you can use them in your code. First, let's define what a generator is. A generator is a special type of iterator in Python. Unlike regular functions that return values all at once, a generator yields one value at a time. Instead of using the return keyword, it uses the yield keyword to return values. This allows the function to pause and resume where it left off, making it memory efficient. Here's a simple example. We have a function called count up to, which generates numbers from 1 up to a specified limit. Notice that we use the yield keyword inside the while loop. Every time we call next on the generator, it yields the next number. This process continues until the generator is exhausted. So, why use generators? The main advantage is memory efficiency. Generators don't store the entire sequence in memory. They yield one value at a time. This is especially useful for large datasets. Additionally, generators use lazy evaluation, which means values are computed only when requested, leading to faster performance in many cases. Let's compare a list-based approach to a generator-based approach. In the list-based example, we return a list of squared numbers all at once, which can be memory intensive. In contrast, with the generator, we yield each squared numbers one by one, making it more memory efficient, especially for large values of n. Generators work seamlessly with loops. You can iterate through a generator using a for loop, and it will automatically call next on each iteration. This allows you to process items one by one without needing to load everything into memory upfront. Generator expressions are similar to list comprehensions, but they use parentheses instead of square brackets. This makes them more memory efficient since they return a generator instead of a full list. In this example, we are squaring numbers, but we are doing it in a way that does not require storing all the results in memory at once. Generators are also useful for processing large files. In this example, we define a generator that reads a file line by line. The generator yields on one line at a time, so you don't have to load the entire file into memory, making it ideal for processing large files efficiently. Generators can even be used for creating infinite sequences. Here, we define a Fibonacci generator. Instead of calculating the entire sequence, we use yield to generate each Fibonacci number on demand. This allows us to work with infinite sequences, one number at a time. Generators can also be combined with functions like map, filter, and reduce. These functions allow you to apply transformations or filters on the values yielded by a generator. For example, we can square the numbers, filter for even results, and then accumulate the sum of those even numbers, all using generators. To sum up, generators are a powerful tool for efficient iteration and memory management. They provide benefits like lazy evaluation, which computes values only when needed, and they are ideal for working with large datasets, infinite infinite sequences, and real-time data processing. Understanding generators can help you write more efficient and scalable Python code. Hello and welcome to this presentation on iterators in Python. In this session, we will explore the concept of iterators, how they work, and how you can create custom iterators for your Python programs. Let's dive in. Let's start with an overview of iterators. An iterator is an object that allows you to traverse through all the elements in a collection, such as a list or a tuple. The key to an iterator is that it uses two methods iter to initialize the iterator and next to retrieve the next item in the sequence. Why should you use iterators? Well, they are great for efficient memory usage and simplify the process of iterating through large or even infinite datasets. Now let's look at the two main methods of an iterator. First, the iter method. This method initializes the iterator and returns the iterator object itself. It's required to make an object iterable. Next, we have the next method. This method returns the next item in the sequence. When there are no more items to return, it raises a stop iteration exception, signaling that signaling the end of the iteration. Now let's see how can you create a custom iterator. Consider the following example where you can create an iterator that behaves like Python's built-in range function. In this example, we define the init method to initialize the start and end values, iter to start the iteration, and next to increment and return the next value. As you can see, custom iterators allow you to define your own sequence logic, making Python even more powerful for various use cases. Python provides built-in iterables like lists, tuples, strings, and dictionaries. You can easily convert these into iterators using the iter function. Once an iterable is converted into an iterator, you can use the next function to retrieve items one by one. Here's a simple example with a list. By calling iter on a list, you get an iterator, and using next, you can access the elements sequentially. One of the most common ways to use iterators is with a for loop. The for loop automatically handles the iteration process by calling iter and next behind the scenes. With this, you can loop through all the elements in a collection without manually managing the iteration. This makes your code cleaner and more readable. An important concept when working with iterators is the stop iteration exception. This exception is raised when there are no more items left to return in the iterator. You can handle this exception in your code to gracefully handle the end of the iteration. For example, you might use a try block to catch the exception and output a message when the iteration ends. Now let's look at some exercises to practice what we have learned. First, try creating a custom iterator for generating the Fibonacci sequence. Then explore how you can create an infinite iterator that generates numbers indefinitely. Another exercise is to build an iterator that reads a file line by line. Finally, try using zip to combine multiple iterators into a single iterator. To summarize, iterators are a powerful feature in Python that provide an efficient way to traverse through data. We have seen how iterators work, how to create custom iterators, and how to use built-in iterables with for loops. Understanding iterators can help you write cleaner, more memory more memory efficient code, especially when dealing with large datasets. Thank you for joining this session, and I hope you now feel more confident working with iterators in Python. Welcome to day 27, Regular Expressions in Python. Today we will dive into the world of regex, learning how it helps us search, match, and manipulate strings. We will also explore Python's re module, which makes working with regex easy and efficient. Let's start by understanding what regular expressions or regex actually are. Regex is a sequence of characters that forms a search pattern. It's used to search for specific patterns within strings, making it a powerful tool for text processing. For example, the below example is matches a social security number. Regular expressions are built using basic components. Literals are characters that match exactly. For example, A matches the character A. On the other hand, meta characters are symbols that have special meanings. For example, backslash double backslash D matches a digit, 2 backslash W matches a word character, and now let's look at quantifiers and character classes. Quantifiers define how many times an element can appear. For example, asterisk means 0 or more occurrences, and nm means between n and m occurrences. Character classes allow us to specify a set of characters to match, such as ABC, which matches either A, B, or C. To use regex in Python, we import the re module. There are several useful functions in re, such as match, which checks if the pattern matches at the beginning of a string, search, which finds the first match anywhere in the string, and sub, which allows us to replace patterns within strings. Here are examples of how match and search work. Re.match looks for pattern only at the start of the string, whereas re.search searches the entire string for the first match. For example, re.match r, r prime a b c prime. Next, let's look at re.findAll and re.sub. Re.findAll returns all occurrences of the pattern, while re.sub replaces the matched pattern with a specified string. Meta characters like the dot are used to match any character except a new line, while anchors like match the beginning and end of a string respectively. One of the powerful features of regex is capturing groups. By using parentheses, we can group parts of the pattern and refer to them later. Back references allows us to match the same text as a previous group. Let's now look at a practical example. Here we are using regex to validate phone numbers in the format given below. The pattern ensures that we match exactly 3 digits, a hyphen followed by another 3 digits, another hyphen, and 4 digits. Here's another practical use case, extracting dates. For example, we can extract dates in the format DDMMYYYY using the pattern below. This allows us to capture the day, month, and year separately. For your mini project, you will create a regex based text parser. The task is to open a text file, use regex to extract information like email addresses, phone numbers, and dates, and then display or store the extracted data. Let's quickly recap. Regex is a powerful tool for searching, matching, and manipulating strings. We covered key functions like read.match, read.search, read.findAll, and read.sub. Now it's time to practice. Try validating phone numbers, extracting dates, and validating URLs using regex. And with that, we have covered the basics of regex. If you have any questions or need clarification, feel free to ask now. I am happy to help. Hello and welcome to day 28 of our Python course. Today we will be working on a practical mini project where we will create a file parsing tool using Python. This tool will help us read, process, and extract useful information from files. Let's get started. First, let's understand the objective of the project. The goal is to create a tool that reads a file, processes its content, and extracts useful information based on specific patterns using regular expressions. We will work with file handling and regular expressions, two key concepts in Python that you will need for this task. To begin with, we need to set up our project. We will create a folder for the project and include two main files. Input.txt, this will contain some sample data, file underscore parser.py, the Python script that will handle the file processing logic. For the input file, you can include data like emails, dates, or phone numbers, anything you want to extract. Next, let's look at how we will read and write files. In Python, we can use the open function to read from a file. Here's an example. With open input.txt, r as file, content equals to file.read. This reads the entire content of the file. Once we have processed the data, we can write the results to an output file like this. With open output.txt, write as file, file.write parsed results. This will allow us to capture and save the parsed data. Now let's dive into regular expressions or regex, a powerful tool for matching patterns in text. In our tool, we will use regex to extract specific data such as email addresses. For example, we can use this pattern to match email addresses. By using the re.findAll method, we can extract all email addresses from the file content. Once we have extracted the relevant data using regex, we need to display or save the results. We can look through the extracted emails and write them to the output file like this. With open output.txt, write as files, file.write extracted emails. Then loop through and write each email to the file. Alternatively, we can print the results directly to the console. Both methods will help us verify the data we have extracted. There are a few enhancements we can make to this tool to improve its functionality. We can allow the user to input the file and specify which type of data they want to extract, like emails, dates, or phone numbers. We can also add support for multiple file types like CSV or JSON and parse them accordingly. Lastly, we can modularize the code, breaking it down into functions for reading files, applying regex, and writing results. This will make the code more organized and reusable. Here's an example of what our input and output files might look like. If you have an input file with text like below, after running our parsing tool, the output file will list the extracted emails, that is john.doe@example.com, jane.doe@example.net. To wrap up, this mini project has helped us learn how to work with file handling in Python and use regular expressions to extract specific data from text. We also saw how to output the results and make enhancements to improve functionality. This is a great hands-on exercise for reinforcing your Python skills.